If we are asked to find the axis of symmetry and the vertex, and our equation is given to us in standard form, one of the options that we have is to take and find the x-coordinate of the vertex by taking the opposite of b divided by 2 times a. And so we're going to say that the x-coordinate of the vertex is equal to the opposite of b, which would be -2, divided by 2 times a, which is a -1. Remember that a is the coefficient of x squared and that b is the coefficient of 2. So we'll have -2 divided by -2, and therefore the x-coordinate of the vertex is 1. That gives us the x-coordinate of the vertex. It also gives us our axis of symmetry. Now we're going to go back into the original equation, and we're going to substitute in wherever we have an x, we're going to put in 1. And so when I substitute in here, I'm going to say that I'm going to have f of x, or y, is equal to the opposite of x squared plus 2 times x plus 3. And you can see that I've substituted that value of 1 into the equation for a place of x. And when you follow order of operations there, you would find that the y-coordinate is 4. If we are looking at for the axis of symmetry and the vertex in number 2, you've got a couple of options. You might look at this and say, if these are my factors here, then I know that there is an x-intercept at -3, 0, and an x-intercept at 1, 0. And if I know what I know about the vertex is that it has to be the midpoint between those. So if I take -3 plus 1 and divide by 2, I'm going to end up with an x-coordinate of the vertex at -2. And so that gives, at -1. The x-coordinate of the vertex is -1. The axis of symmetry is -1. The alternative to doing that is that you could multiply this and put this into standard form, and then it would be a problem like this over here where you would identify the a and the b and do the opposite of b over 2a to find the x-coordinate of the vertex. That step would give us the same thing. It would give us that x is equal to -1 for the axis of symmetry, and the x-coordinate of the vertex is -1. To find the y now, we're going to go back into the original here, and I'm going to put in x. Instead of x, I'll put in -1 plus 3 times x, which is -1 minus 1. So -1 plus 3 is 2. -1 minus 1 is going to be a -2, and that's going to give us a y-coordinate of -4. The discriminant, remember the discriminant is b squared minus 4ac. And so if we look at this, our a is -1, our b is 2, our c is 3. If we plug in here, b squared, 2 squared, minus 4 times a times c, and use our calculator, our discriminant should be 16. Since that is a positive discriminant, then it tells you to keep working the quadratic formula, that quadratic formula is going to have 2 solutions. Remember that if this discriminant number were negative, we would say that there's no real solution. We'd stop doing the problem. If this discriminant is 0, we would say there's 1 solution. Okay. So moving on over here, b squared minus 4ac. Our a would be 2, our b is 0, our c is -24. So we're going to have 0 squared minus 4 times 2 times -24. That is going to give us 192. A positive discriminant tells us there are 2 solutions. Okay. Moving on, we are to write factored form and standard form from the graph below. So if we look at this, I can see that right here, that is the point -1, 0. And that right here, that is the point -3, 0. So those would be our factors. Our A value is positive because it's open up. So I'm going to have that f of x, our function, is equal to, we can have a 1 here, but we don't really need it because we know it's implied to be there. If our factor's at -3, then, sorry, if our intercept's at -3, our factor is x plus 3. If our intercept is at -1, then our factor is x plus 1. If we're going to take and put this into standard form, that just means that to get from here to here, that I need to multiply from factored form into standard form. So I'm going to take this x and multiply it by x plus 1. I'm going to take this 3 and multiply it by x plus 1. Use the distributive property here. And combine like terms. And that'll give me x squared plus 4x plus 3. Now let's look at what we know here. What we know is that my constant value is the y-intercept. Let's take a look and see. Is the y-intercept 1, 2, 3 at 0, 3? So we can verify that we have that correct. A -4. All right, so we're looking here, to be able to graph. If I look at this, first thing I notice is that I have a negative here, so I do know that this is going to be open down. If I look at this, I'm in factored form. And so I can very easily find my solutions intercept zeros. If this is x minus 2, then I'm going to have an intercept at +2, 0. And if this is x plus 4, I'm going to have an intercept at -4, 0. So I can get those plotted. Here is 2, 0 and -4, 0. It asks us what is the vertex. We can look at the vertex by saying if I have 2 as an intercept and -4 as an intercept, if I take the midpoint or average of those, I'm going to end up with -2 divided by 2. That's going to give me -1. So here is where I'm going to have my axis of symmetry at x equals -1. Now I also know that this was negative, and so I know that it looks something like this. So I know that my y-coordinate, my vertex, has to be positive. Okay, so I'm going to go now, and I'm going to go back into my original y equals negative, and then in place of that x, I'm going to put in here and here a -1. So I'm going to have -1 minus 2 and then -1 plus 4. And let's see if this makes sense. So -1 minus 2 would be a -3. -1 plus 4 would be a 3. And so what will happen here is that that'll give us a +9. We were expecting a positive because we know that that had to be based on the shape of our parabola. And so our vertex, the x-coordinate will be -1 and the y-coordinate will be 9. That is our vertex. If we go ahead and plot that point, -1, +9 will be right here. And then we can use our pattern. If we start the vertex, go over 1, down 1. Use symmetry to do the other side. Go back to the vertex, go over 2, go down 2 squared, which is 4. use symmetry on the other side. The next set of moves would be to go to the right 3 and then down 3 squared, which is 9, which puts us at our solutions. And you can now see that we have our parabola. So even though it might only be asking you to write out the solutions and write out the vertex, you had to know not more about how to graph to be able to create the graph and those points accurately. All right, so let's look at the next one here. Try to make it a little bit larger. Okay. All right, so looking at this one and ask us what is the axis of symmetry, which means we have to find the x-coordinate of the vertex. And so what we could do is, since this is in standard form, we can say that x is equal to the opposite of b divided by 2a. b would be a -8, and so therefore the opposite would be a +8 divided by 2 times 1. And when we do that arithmetic, the x-coordinate of the vertex is going to equal 4. And when we go back into the original equation, and if we substitute 4 in here and here, we're going to have 4 squared minus 8 times 4 plus 16. And when we do that, the y-coordinate then is going to end up equaling 0. And so we are going to be at the axis of symmetry that it asks us for is going to be x equals 4. But we went ahead and also found out, because it's going to help us complete the graph, that the vertex is at 4, 0. Okay. So we can go the vertex at 4, 0. And if we look at this, that this vertex is actually doing double duty, because that is also our solution, our x-intercepts are 0 points. So we could have also found that out by, if we were to take and factor this, this is a perfect square trinomial. And if we were to take and set that equal to 0, we would see that we have an intercept at 4, which is 4, 0. So this point is our vertex as well as our 0 point. But I knew here that my a value is 1, which is telling me that I'm going to open it up, the parabola. And so I'm going to move to the right 1 and up 1. Use symmetry to fill in this point. I'm going to go to the right 2 and up 1, 2, 3, 4. Use symmetry to fill in over here. I'm going to go to the vertex and I'm going to go to the right 3, and then I'm going to move up 9. We can see that we won't be able to see the y-intercept, but the y-intercept given to us here as the constant is 16, and it makes sense that if we were going to go and move to the left 4, 4 squared is 16, we would be at 0, 16. So remember, we said it's like a puzzle, everything has to fit together. You could definitely use the y-intercept to check to make sure that you're on the right path. All right, and our last one here, x squared plus 8x plus 15. If it asks us what the vertex is, we can say that x is equal to the opposite of b divided by 2a. That would be, our b value is 8, so the opposite is a -8 divided by 2 times a is 1. That is going to give, that is going to give us a -4 for the x-coordinate of the vertex. And then I'm going to go back into the original equation. I'm going to put -4 for x here and for x here. So that'll give me -4 squared plus 8 times -4 plus 15. And so when I do that arithmetic, I'm going to get -1. And so the vertex is at the point 4, -1. So I'm going to go to 4, -1. Since this A value is a +1, I know that it's opened down. I know that it's opened up, and therefore my vertex will be here. And therefore that means that since it's at the bottom there down, that will be a minimum value. All right. I'm going to erase this point because I think I wrote it incorrectly. This is a -4, so our point should be, or vertex should be at -4, -1. Okay. From there, we're going to go ahead and complete our pattern. So I'm going to move up 1 and right 1 and use symmetry. Now it didn't ask us, but if it asks us for the x-intercepts or the solutions or the roots or the zeros, we just found them, and that would be at the point -3, 0 and at the point -5, 0. Okay, keep in mind that we also could have found them by taking this and factoring what two numbers multiply to 15 and add to 8, that's +3 and +5. And when we take those factors and solve for intercepts, you could see we'd have -3, 0 and -5, 0. Now on this particular problem, it didn't ask for what I wrote in blue, but I'm just showing it to you so you make those connections. And now I'm going to finish here by plotting the rest of my points. I'm going to go to the right 2 and then up 1, 2, 3, 4. At this point, it says graph 5 or more points, so you would have 5. You could go one more and do 1, 2, 3. 3 squared is 9. Move up 9. 5, 6, 7, 8, 9. And we could see that, even though we can't fit that on there, that the y-intercept is to be at 15. And you could see we're at 8 here. And so if we moved again, it makes sense that we will be at 15. And then here is our parabola.